everyone. Today we are going to start a new series of Nirmaan under IITG SP student chapter. Recently we have heard a lot of terms about like digitalization, predictive maintenance, AI in like refineries. So these terms are not new in today's world, right? So these are the terms which have been used in each and every industries. So the engineering is not only limited to just only with processes and equipments, but also with the data, decisions, and how you use that data in refineries. In this podcast, we are having this podcast with our speakers here. So first we like to introduce to Dr. Opinder Bhan, who is a senior principal advisor, and also he has worked under the area of hydro processing and refinery innovation. Also we have ma'am, Ms. Sushma Bhan. She is a technical director at SPE, data science engineering and analytics, and also former Shell data officer. Okay, so first of all, sir, I would like to thank you all for coming here.
Sure.
Before starting this, I would like to ask a very few questions, sir. Like, how you started your career in this field, like doing specifically on the hydro processing part?
I came into United States in 1978. I initially enrolled for a master's degree, and in the master's program itself, I got introduced to the science of catalysis in the university itself. Luckily, I ended up with a PhD also in catalysis. So then the first job I got was with the Department of Energy, and they were also trying to convert some of these old, heavier fuels like lubricating oils. How they were trying to refine them. So I ended up with that one, and that was also catalysis. And then finally I ended up with a job with Shell, and in that job also that specifically was in the area of catalysis because Shell had the second largest hydroprocessing company in the world was operated by Shell. So I ended up in that area and I continued doing the work in that area. But really the key thing that I did was I branched out into a lot more areas which were related to the catalytic operation because catalysis itself is very vast so that's how I ended up with so many years in catalysis.
Sir, when you started your career in this, so from like when you joined the industry and you work, and like where you were doing your PhDs, and when you joined the industry, and right now what you are seeing the scenario. So what changes have you observed? Like what changes?
Oh, there has been an amazing transformation. Let me really take you back to the days that I grew up. I went to the Regional Engineering College, Srinagar. So at that time, the computers, there was only a few computers in India, okay, let alone small computers. They were mainframe computers. And our teacher in the 7th semester told us that, hey, listen, you need to learn this language. It's called Fortran. But unfortunately, there's no computer in here. I'll teach you just how to write the code. So we learned how to write the code with a paper. So I learned it really well. So when I came to the United States, we realized that there's a big IBM 370 computer and I have to learn it because my professor said that, hey, you have to program the equation of state. I said, I don't know how to program it. He said, you have to learn it. So I learned very quickly. So what I'm saying that, and from there, then came the transition to the PCs. So everyone started using PCs. That people started saying, hey, before we had Lotus. So Lotus 1, 2, 3 is what we used to do. And then I came to Shell and they were using Excel. I said, so suddenly I had to learn how to do Excel. Then from there, we gradually started going into what's called the high-throughput processing, meaning that Exxon suddenly started developing these processes, saying that rather than doing one catalytic reaction at a time, we can do 1,000 catalytic reactions at a time. So I had a chance to learn what does that mean. So I went to the management of Shell. I said, hey, I need money because we need to compete with Exxon. When I said Exxon, they said, yeah, we need to go compete with them, because when you bring into the point where you tell the company that you're lagging behind because otherwise the competition is going to, then they will provide you the money. So they gave me the money for that. So we went into the high throughput processing. High throughput processing meant that you could go ahead and do thousands of experiments at a time. For that, I needed robotics. So we did the robotics, started developing. Actually, I helped 3 companies to get germinated in Germany and in Switzerland and in Netherlands. And the 4th one was in the United States. So we formed these companies to do this type of, then we started using this, suddenly realized there's so much data coming through. What do you do with this data? How can you analyze this data? So we started another company in England that was able to started a system for us where we were able to bring all the data together. And then we started getting the statisticians who use SAS. How do you make sense of all this data? So these guys started making models. Okay, then we said, okay, we know now we have the experimental data, we have the statistical data, we have the data itself. How can we go now figure out from this data, can we make anything better? So we started what's called the knowledge management of that one. Take that data, and from the data try to figure out what is the next step. And then came the AI portion, which is like bring all of this and let AI tell you what your next 1,000 experiments are going to be. So it's a huge transformation. And I really have to tell you also this thing, the time I grew up, the first time I had to write my first letters, I had a wooden board, you probably would never even know, and a bamboo stick that as a child with a razor, we used to cut it, and they used to make clay. With a clay water, we would write. That's how I learned basically how to write initially. And from there to AI. So we saw the whole gamut.
So that means what the whole process is not specific to like specific domain. It's not related to specific domain. Like if you want to do excel in every field, means you have to know a little bit about like whatever the opportunity it comes in your life. You have to learn each and every part.
Exactly. I think that's a very important, that's something I wanted to emphasize. So the question was asked in the morning that AI will impact. I think the basic thing is that people, first of all, need to have, number one skill one needs to have is mathematics. You have to know mathematics very, very thoroughly. Not only advanced mathematics, but even doing simple mathematics like arithmetic in your head. That's very important because you can do algebra in your head. You need to understand geometry really well. You need to understand calculus really well. And eventually you need to know differential equations, right? And integration. So those are, with that, if you have that and you have linear algebra, or you don't need to go to partial differential equations or all of that, because those are not necessary. As long as you know the basics, you need to know physics thoroughly, right? And you need to have a good background in chemistry if you're a chemical engineer. Really, very, very good. So if you have these 3 things, from there you can graduate into anything you want. You can, then if I look at chemical engineering courses, which have been core courses for me, 1, reaction engineering. That's a fundamental thing. You cannot become a chemical engineer and not know reaction engineering thoroughly. You need to know thermodynamics. Absolutely necessary to understand PVT equations, how the gas equations are happen. Those are very important. Heat transfer and then mass transfer. So these are transfer, and which is really transport phenomena. So really one of the biggest inspirations in my life have been 3 books. One was Levenspiegel's equation, reaction engineering. Number 2 was Peter's book on plant design. Peter's book in plant design. And number 3 was one of the calculus books by Thomas. Probably you don't need it, Thomas. Amazing, amazing books. If you understood those, I even go back even now to look at those. So those are the fundamental things that if you have that, then you can branch out in anything. And like you said, one of the things I'll realize in my life is not to say no to something. When an opportunity comes in, it's not going to come knocking twice. It only comes once. When your boss says that, can you do this thing? If you say, I don't know, I have too much busy, I'm not doing this thing, I always said yes. Okay, I do that portion, I learned that portion, then boss comes back again. It says, can you do this thing? I say, yeah. Add on this thing, add on. So when you add on more responsibility in life means you will advance more. You will have more knowledge, more people will be influenced by you. So the influence portion is very important too, because like you need to influence upwards and you need to influence downwards, meaning that you need to bring this people who are not as bright or who are not doing as well or who are like your technicians, your other lower ranks, you need to bring them all up. At the same time, you need to have a clear, developed relationship with management at the higher level, even up to CEO, and I was able to go to the highest level of Shell, be able to propose and you have to be very concise. When you go to the higher management, if you give a lecture for 20 minutes, it's of no value to them. Within 30 seconds, can you convey the idea to that management and tell them, hey, this is useful? Do that. So that is communications is another thing that's extremely important. How do you communicate? You need to understand, you need to view the audience and say that, how's the audience doing? Are they interested in this thing? If they're not, you switch off. Same is true of the higher level. You gotta be concise, you gotta be focused, and you gotta be to the point. So that's so I learned that when she has learned it better than me. She does phenomenally. She's also started. So she's really, really good at all of that. She really can manage this whole gamut, whole spectrum really well. And that's one thing. And then the other thing is the relation. In those, you're really managing relationship. Mm-hmm. So if you don't have that relationship and trust, and then again, I'll say that my customers, I had customers, my biggest customer in India was Reliance. Reliance really, really depended a lot on my input to them, telling them, hey, you're doing this one right, or you're doing this one right, this goes here. They trusted me. Okay. Same is true of many companies in China, Korea, America, Canada, that who really trusted me, because you need to build that trust over years by giving them consistent, positive, and correct information. That's very, very important. To develop that trust is extremely important.
So while you were doing your research, right? So have you faced the importance of doing your research in collaboration with industry, right?
Absolutely.
It's very, very important and very necessary.
Absolutely, it is very important, because you had one person after her talk, one of the persons came to me and talked to me today, and he was asking me about nickel phosphate catalyst. And my question to him was, what is the end point on this one? Where is it going to be useful for somebody in there? Because you can do it as a basic science, then you don't need to. But if you're going to have a technology which is an application technology, you better have collaboration, you better understand economics. That's the other point that I really want to emphasize. As an engineer, people underestimate the value of economics. You need to really understand the economics, because economics is ultimately which determines whether a project will be a go or a no-go. You better understand that and understand the value. So whatever you are doing, you have to look at the economic value. Which are the companies, collaborate with somebody in there, try to figure out what are the requirements, what are the limitations, where are they facing difficulties, and help to identify those, and then how to solve those problems. So it's extremely important. Don't do research in a vacuum. Unless you are a science person, you're doing basic chemistry. I think that's totally fine, because they're doing basic chemistry. That's not the thing.
If you propose any project So you have to take consult from like each and every department, as you have talked about economics, right? So a person who has done majors in economics, he knows about all about the plant designs and everything. So if you want to propose that I want to set up hydro treater here, so you have to, if you are working in a team, you have to mention that why it's necessary, is it economical or not. So you have to be in a collaboration with a team, right?
Exactly. You need to have that. And the person who is doing all this work has to have a feeling what it means, dollars per barrel. How much, what is the enhancement? How much is the cost? What is the project cost? What is the rate of return? What is internal rate of return? All of that economics needs to be understood.
Sir, one question I want to ask, especially I want to highlight here. So in Indian refineries, right now, so people who are working, most of them who are working especially in the government sectors, right? So the work which I have seen, that the work is a bit steady, right? There is no innovation, a bit very less research. People are doing the work our Indian refineries, all the softwares are like from outside. Even our whole technology and innovations are from so in India we are doing the refinery part, right? Maybe we are doing the refinery and the production part, but all the equipments and all the softwares, we are highly dependent on
outside. Yes.
So that's a very point. That's a very problem which we have in Indian refineries, right?
My assessment on this one has been, I'm born here also. The big difference that you asked me, what has changed? The big change that I found when I came to the United States, or I have worked in the United States, that our application is a lot better. Meaning that Indian people understand this and the theory really well. And we will understand the top people will understand, but they also know the application. Meaning that how do you take this idea and you make it into an application? Look at what's happening with AI. So the really top people from India can go, why are they not incubating as many companies here as they're incubating in Silicon Valley or other places? Because the condition is such that they're so driven by the market that either you float or you are able to do something very good. So you can literally, in that place, you're gone. If you're not on top of the things, if you're not innovative, you will not last. It's a highly competitive market, extremely competitive, even from an individual point of view. If you can't compete, you're not going to last.
Another thing I just want to ask, for example, if a person is doing research especially in your field, so according to you, what is next 5 years scope of work, what we have left?
I can tell you a lot about it. First of all, the area of catalyst itself is such an amazing area which is open for more and more research and development. How do we come up with new materials? So the materials, this person also in the morning was asking, that one of the key problems for all the hydrocarbon processing is that they coke up. Meaning that they form coke and the catalyst actually dies off in a certain period of time. How do you use materials which are resistant to coke? How do you make them a lot longer? How do you take the reaction, say the reaction was going to 86%. How do you make it 96%? How do you make it 98%? And how do you make it 99%? Because every percentage point that you increase the reaction, that you desired reaction, and you reduce the undesired reactions means millions of dollars of product improvement. So that is one thing that I see, that materials and the catalyst itself. Then there's a lot of innovation in the area of using newest microscopic techniques and technologies, lasers, how to look at these materials. I was able to see, one of the catalysts I was making, our electron microscopy had gotten to the point that I was able to take pictures of molybdenum sulfide. You could see the molybdenum molecules and you could see the sulfur molecules, actually see them. So you could see that how the catalyst was being formulated because you were good. So now there's another technology which is what's called the high level X-rays, which gives you a three-dimensional picture now of what's going on. So you can also see what the reactions are happening as they're happening. So now then we come to what Sushma was talking about. Now you will have all of the area of the reactor has sensors, temperature sensors, pressure sensors. Now you literally have them in the catalyst itself, and you take a model itself is telling you how the reaction is proceeding, is there a problem in there, and let AI take care of that, what we do from the process control point of view. So there's a lot of, but the ultimate gain is what? Can you increase the productivity and reduce the shutdowns? Because shutdowns is where the refinery loses money.
Yeah. So means increasing the also the shelf life of the catalyst, right?
Exactly. Yeah. Big, because by if the catalyst has less shelf life, that means it has to turn around. Every time a refinery turns around, it's about 2 weeks. 2 weeks of shutdown. To have a refinery that is operating at, say, 1 million barrels per day, think about how much loss of money it is in 2 weeks. Humongous. Talking about millions and millions of dollars is lost.
Okay. Sir, so it's time. So if anyone wants to ask any questions.
Sir, so I have a question regarding as you said, your research area is in catalyst development. So, sir, during we are most of us are the students of chemical engineering with specialization in petroleum science and technology.
Okay.
So we have a subject that is petroleum refinery engineering.
Okay.
So there we have taught about various kind of reactors and refinery units which are being currently used in industry. So there we have been taught a topic in which it specifies that the type of feed which we are going to process in any reactor, so like in a HDS unit or in a reformer unit, the feed contains also the factors that what are the contents of the feed are also very important, crucial for the development of catalyst. Like some feeds are highly sulfur content, the sour crudes.
Right.
So for that we need some catalysts which are like less dependent, which affects less from the sulfur. Some contains more arsenic or heavy metal contents. So while making or while researching on that topic, we have to make we need to consider one type of crude, like one type of material we need to study. So how starting from one basic like nominal type of crude which will be starting, how can we upgrade with different kinds of crudes, and because there is a supply and all problems.
It's a very good question. So what I'm saying is that this is a problem all over the industry. So it's a very important thing, because if you look at the world, there are about 5 different regions that produce oil, and depending on how long the oil has been sitting in the ground, it makes different geologies, and those geologies are dependent on which animal or which type of creature was caught up in there and it made it really. So we have to look at the crude oil like what we did was we took a signature of the crude. So once what it means by signature, you do a whole lot of tests. It's like doing a test for a human being's blood analysis. So rather than doing a blood analysis, we do the crude analysis. So complete picture of how much nickel, vanadium, asphaltene, sulfur, which type of sulfur, nitrogen, asphalt, amines, everything, aniline point. There are so many UOP tests. There's a whole lot of tests. Okay, you have a database now with so many crude oils in there, Arabian heavy, Kuwait, Venezuelan. So then you figure out what is the differentiating factor. And that's one of the things also the AI fits into, that I can see that becomes a potential. Now then you correlate the properties of the catalyst to the properties of the feed that you're processing. That's also an amazing area, and that's where my expertise came in, that I could help tell them that, hey, this crude will be better for this. But then more importantly, if now the refinery has said that, hey, I'm going to use Venezuelan, you tell me what to do. So then we formulate a catalyst system for that specific crude. So like we will put a hydrogen demethylation catalyst upon the top, which will remove all the transition metal catalyst. And we'll put a hydrodesulfurization catalyst, which will remove most of the sulfur. Then we put hydrodenitrogenation catalyst to take out all the nitrogen. Then at the bottom, we'll put hydrocracking catalyst that is going to take the large molecules, make diesel out of it. Because the key thing in refinery right now is to make as much diesel as possible, because diesel is the most profit-wise, it's the best product to have. Transportation-wise, it's easy. Number two, aviation fuel is extremely expensive and is definitely used. Countries like India and China have a tremendous amount of diesel. So what I'm saying that you are directing the catalyst to that feedstock. So refineries, like I have a lot of refineries in the past with this subject. How do you pick up this feedstock? Now you'll say that we have Venezuelan, but then what they do is they also bring in another feed. We mix them together to get to this chemistry of what we want, and then we can set it up. So everything is tailored and figured out what is tied to what in order to be processing it. So that's very important. So like what was said, hey, suddenly we will be using Venezuelan. It can't. The refinery just cannot do it. It's not subjected. But another refinery which is geared towards this type of processing, where we have a vacuum tower and you're able to take what's called a vacuum pitch and take it separately in there and process it, then they're specific to that one. But you cannot just take any crude to any refinery and be able to process it.
Like how much time, suppose if you have to start up an industry, how much time it required like to do complete R&D about that specific route? Right now, industry units approx.
Okay. No, I think it's more important to know not only there's say each unit runs for a year, okay? And you cannot just in that year suddenly now change the crudes to a drastic change. But if you are in a planning stage and you say to the people who are supplying the catalyst to you, hey, I want to go to this feedstock and please provide me the catalyst stack that you will want for this particular seed. So the next time it's changed, you just go with the new stack and then you will be able to process your feedstock. But it's not like suddenly a refinery is using Assam crude and suddenly they will be using Venezuelan crude. No, it's not going to happen. It can't. Yeah, it's customized.
Okay, sir. Okay, I will ask question like both of you can answer.
Okay.
I want to.
I like her to answer them.
So my question is like I want to specifically know that like as you have worked in the industry, so how AI is helping in like safety, like in the safety of a refinery, and what are the limits in which it can cause? Because you always need a person to like watch how the process is going on. So can you say something about like?
I generally with AI, and then you can go a little bit into the refinery. The AI again, is very valuable to help mitigate risks, because it can process a lot of information and data. And so whether you're doing it in the refinery area or in the upstream, it can help more with precision, predictability, and that is what is very key, because anywhere in safety where you have to use human power, you're risking their life, especially if it is dealing with, let's say, deep water operations, or it is in refinery where there might be high pressures and temperatures and things like that. So the key thing with AI is if you can gather the information and data and you can analyze it, you can forecast, what is happening, whether it's about equipment failure or you can forecast, the conditions. You can prevent many of the things that could happen when you send human beings there. So I think that is the crux of the thing. You gather the information and you analyze it. One of the things that is happening now is not only are you using that for predictability, but you can also use it for decision making. But that is done more and more when you have test data and it has been trained that you can rely on AI to do some of the decision making. So while you can not have human beings to react and do something immediately. Let's say there's a spill or a drastic condition. It has to be trained enough to have enough of information and tested well enough to mitigate risks like that. So again, I mean, the opportunity is there as long as you have foundationally put your science and math and testing behind it, and then you can sort of trust it to do it.
So if I work in an industry, like I have to find that where oil is present. Like for example, so I need the knowledge of geologist, right? So you, from your talk, you said that you need like domain expert to say. Suppose for example, I'm a data scientist and I have learned data science doing predicting the stocks and like. So I am new to this petroleum field. But I do not have any knowledge about this whole petroleum field, maybe in the refinery section, maybe in the medical section. So, am I credible? Will I be credible for an industry because I do not have any core domain knowledge, but I have good ML and AI experience.
Yeah.
So, which is
So we have seen that when we have started the teams. Normally, most of the teams are multidisciplinary because you cannot have one person who knows in depth all the areas. But normally when we get the data scientists to work with, whether it's working in the upstream area or the downstream area, they definitely come with good computing, math, science, the application skills. They still have to understand a little bit of the domain. But the key thing is they then team up with an expert. So let's say you come as a data scientist and you need that, you're leading that area. Then you team up with somebody who's a refinery guru, and then you team together, communicate, and develop, an effort that will take both the skills and know-how and work it forward. It's never done in a silo fashion. And he too has to understand, what is the data scientist trying to do? What are the things he has to understand? And likewise, you have to be able to understand what is the language he's speaking. So it's very, very key that you sort of build the hybrid skills. You don't necessarily have to be an expert, and that's for me too. Like when I started working in exploration, we were embedded with petrophysicists and people who had geoscience know-how, and by working with them, we were picking, and also we took training classes. We took a lot of geophysics, petrophysics, basic. When I was working in what's called the well reservoir facility management area. I took like a week-long class in production technology.
so
what I'm saying is you have to skill yourself enough to understand, comprehend, so that you can take your domain expertise and be able to help the other person.
your course were basically software related or maybe
I came mostly from computer science and then with the MBA, but I worked right from the beginning from
the industry which they actually taught to the engineers, like the industry's course, they are basically software dominated or like the core domain?
No, mine was from computer science. I worked in the airline industry first.
No, but he's asking you when you trained them, what type of train? Like you said that you went for actual operations training to learn the training portion of it.
Yeah, I learned about the
industrial.
The industry, the domain,
Yeah, he learned.
I understand, what is involved in the wells, reservoir. And that's I want to put a pitch for SPE. The reason I joined SPE was also because when I was working in wells, reservoirs, facility management, which is very multidisciplinary, and I was coming as, a person who was leading the whole technical data initiatives for multinational projects. I just was curious and I had this learning desire to understand, what's happening in the wells, what's happening in the seismic geophysics area, what's happening in the production area. And I was sort of going to these different sessions, listening to some, webinars and technology people. And not that I understood everything, but it was trying to soak in, what are the big issues, where can I connect with my data information know-how or computing. So what I'm saying is people have to always multi-skill themselves. You have to be able to understand. So I had to learn a lot of domain knowledge in the exploration and production area. And I would say that, I became a reservoir engineering expert. Even when I was working in chemicals, we were conversing with the people who were embedded in the chemical plants area or refining area, understanding, what are the issues they deal with. So that is for
And terminology too.
yeah. So it really helps you, and I think he can talk about like refining when you worked with like people who were running your projects from knowledge management.
Yeah,
You have to understand what they're
we have to understand both sides of the equation. Really, you have to understand what their processes require. What are they needing? What are they needing? Really, that was a key thing. So it was also a lot of interaction with our vendors, trying to understand what they had, how they what are our systems, what is communication protocol between the system, which one. So those are very important. But now going back to what you were originally asking for, safety, it's definitely would be extremely embedded. Like Sushma was giving an example of H2S, I'll give an example of H2S. Before, we used to all wear these monitors. I don't know whether you guys do that too. There's an H2S monitor at certain 1 ppm or half a ppm, it will go do it. So it'll beep, and then at 8 ppm, H2S becomes fatal. Yeah, because at 1 trillionth, you can smell it. But by the time it is 1 ppm, you cannot smell it anymore. So, like in a refinery or in a production facility, sometimes there's H2S. So, if a person goes wearing this monitor on, they're in there, they're dead. Right? Because it's going to hit them before it will beep. How does it matter? Because they're already gone, because more than 10 ppm has hit them. So now I'm just giving you an example of H2S, but it can be all kinds of examples to hydrogen. So there are sensors all over the place. So constantly they're looking at and trying to figure out what concentrations are all over. And then how does AI come into this picture? Now, all the areas, all of the data is coming to you. Now you have a new shift coming up, okay? They're getting ready. AI is going to say, hey, stop, because online 24 hours is trying to figure out whether this shift needs to go or not, so it can stop. So it can be safety-wise, it can be tremendous. The same is true of hydrogen. Like, those sensors, there will be sensors which are like gas sensors. There can be thermal sensors. So those are there can be IR sensors. So there is so much now. All of this information is coming in there. So it's not that who makes sense of this thing. That is the important part of it. So somebody has to do monitoring all of these variables at the same time and be able to make decisions on the go. That's why I think AI is going to be very useful for that type of application.
The morning I was talking about, you have the robots,
Gas
people are walking the refinery floors, and they have all these sensors. So they are already gathering, like at night shift, or they're picking it up, just like a little sniffing dog. The robots are set with all the different parameters, and before any shift comes or personnel come, they've already signaled that data back, and it has been processed, and your algorithms have already assessed and said, what are the conditions, whether they are safe or not. Likewise, when you have remote monitoring, using drones or satellite data, they do the same thing, on the refineries, on areas where you have, again, heat and pressure and things like that, or deep sea.
So generally in our industry, like especially if I talk about Indian Oil, so as my father has been working there, so he sees that most of the problem is related to safety, especially in Indian refineries. So if you talk about like Haldi refinery in West Bengal, so there was one blast where the laborers were doing hot job near a plant where there was methane leak. So due to that, like 15 people died. So similarly in other places, like as he mentioned, like H2S, so from there also 2 people were like severely injured. So these type of things, the AI safety concern, especially in Indian market, is not so, like, people are not aware about it.
That's a big problem in India. Like when Shell started operating in India, one of the big things for us was safety. So one of the things that we really push for in safety is do not go above 6 feet without having harness. Have a helmet all the time. Have shoes which are really fitting shoes. Then that was unheard of in India. So by having sensors, that makes the biggest difference. So what happens in a lot of cases, their sensors may be there, but people shut them off. That's one thing. People shut them off. And number two, sensors go bad. So you're talking about India. Even in United States, the BP refinery, they had a column where they had C4. Okay, C3, C4. They had alarms on a distillation column at 3 different places. One was turning bad, the other was turning bad, and they were not replacing it. So what was happening is a cloud of propane was coming out, and it was going in. It was sitting there. There was no detector. Otherwise, it should have been detected. 3 layers of detection were bypassed, and then these guys were doing a hard job right there. They did it. Boom. 8 people or 10 people died in that blast.
We have to make another arrangement for like looking to the backup of the sensors also. Maybe.
Exactly. That's what I'm saying. That.
And I want to add that it's not just about technology. It is about setting the culture.
Yeah, culture.
And it is also about accountability. That if you do not do something, then what will be the consequences of that? You can lose your job. You can lose your life, of course, but there are implications. So I think in major companies that they have made safety an integral part, but then, they are mitigating these risks already by robots, remote sensing, and then analyzing this. So it's more predictive, more decision making can be done in a more proactive manner. And I think that cultural shift is already happening in India. I saw that when I was at ONGC, the first thing they started was with the safety talk and so forth. So I think it's a question of just time and setting up that.
Yeah, bigger companies, but not at the smaller companies.
It's not something that can be just put aside, because companies all see that there's a value to it. We call it the license to operate. Safety is a big mantra, and it's embedded in your processes now.
So, ma'am, actually, I have a question about safety. So, actually, last year I have got a chance to work in Reliance for my internship. So, at Reliance, we are working on the natural gas fields at the Bay of Bengal. So, all our wells are actually the subsea wells. So, while processing the gas, we have a huge pressure differences. Like half of our subsea system is being made to work for ASTM 1600 standards, and half is for ASTM 800 standards. So in that type of condition where the huge pressure differences, there are a lot of combustible gases. At company like Reliance, we have a lot of safety procedures, lot of safety protocols. We have different type of sensors and all that, which are already being used in the industry for the end purpose. So with this kind of sophisticated setup, if one has to implement the AI using that, so here is already we are getting a lot of data, and since the plant has been working for almost 10 to 20 years, so we have a huge amount of historical assets as well. So with this kind of all this data and a sophisticated setup, you have dedicated a team of safety people who is continuously monitoring all the sensors and all the data. How can we pitch, or how can one introduce AI in a already working, highly secured environment to further enhance the safety? Because many times, say, sensors fails, accidents may occur. So how can, with such sophistications, like the industry usually always tries to have the techno-economic behind the thing.
So I think I don't know the whole scenario, but the key thing is you have to look at, despite of all the people and measures, where do you have the misses? Where are the areas that you're still not able to meet? And the other thing is, you said that they have a team already doing it. So if you have, let's say, 20 people monitoring, and you can say, can it be done with just 2 people? Let AI help you assess and analyze, and can you optimize it? So that's where you can use AI, whether it's fit for purpose. You don't have to do AI just for the sake of it. You have to see where it fits the needs. What problem are you solving? Are you trying to make sure there are no more mistakes, like zero? We had a goal that we should have 0 incidences. So if you still have, where can you use? Is it about, interpreting and understanding the data, because it's already been gathered? The other is can some of the human analysis be taken over by the AI algorithms? But again, they have to be designed, they have to be tested and implemented for the right usage. And finally, you can always have use like agentic AI to make the decisions. Like it already knows that, hey, this is happening, so it's not going to wait for this will need to say do a shutdown. It will say, yeah, this is alarming, shut it down, and the AI will shut it down. So I think, but to reach that level, you have to make sure it's working well, it's being tested, all the SMEs have given it. But sometimes that would be, kind of the make or break thing. If you know that explosion is going to happen and you can do it just by changing the valve or changing the pressure, then why not rely on it? Provided you have trusted that. So I think there are going to be a lot of examples where you'll reach that level. It will minimize the personnel, the risk to people, the cost, and your dependability and trust will increase. So I think that part is going to come. But first you'll see what are you missing. Let's start with that. I don't know if you...
Yeah, that's an excellent example. Like really, can we reduce the cost? And can we make sure that it's able to make a decision faster than what you have otherwise? Now, if you have to make a decision here, hey, you got to go ahead and find the superintendent of the place. Yeah. Now you got to go ahead and get the signature from this one. But if your system is so robust that you have, hey, you got to do it, it will save the materials as well as save the lives, assets and lives, that's what you want. So that's, like she's right, it's just a question of time. Because everyone will develop AI for their specific purpose. So it will be like Shell will have its own operations, BP has its own operation, Reliance will tweak everything to the specific. And the other thing that is also very important, you have to realize that the model, the chips right now, the H200 has so many transistors on it. Now there comes the next one. The next one that is coming is the Rubin. That has got nearly 1 billion, already millions times more than what we have right now. And the next one that is coming out is even millions times more. So what I'm saying that what you have developed, hardware is going to be so far ahead of what the software is going to be doing. You will have so much more available that what we are thinking right now is kind of like, hey, is it possible? It will become possible maybe in 3 years because the hardware technology is moving so fast. And that is also very important. So now the question will be, will the hardware technology become so good that it really is going to be, I'll go and ask him, hey, what should I be doing today? No, I'm not kidding about this thing in the morning. That what should I be eating today? Because it already knows my system. It knows everything about me. Whom should I be talking today? So how much time should I spend with Sushma versus how much? I'm not kidding. This is going to happen. Everything will be, because your levels are going to be so enhanced. Already. My son who is in, he was saying that with the Claude, with the Anthropic, people can do 10 times faster, 20 times faster. Look at the programs that it writes.
But the key thing is again to be understanding with the end goal in mind.
Yeah.
Then knowing what problem you're solving, where you're going, is it about cost, and then apply the AI.
Yeah.
Because as you're saying, hardware will be there, technology will be there, and human mind has to decide. Management has to decide. Yeah. Because ultimately they'll say, "Oh, we have done this. Then what is the return on investment, right? Whether it's in savings, whether it's in the life saved or time, and you have to justify that. There is a cost to all this."
Okay, ma'am. So we will be ending today's podcast, and I hope you have enjoyed, and we also have learned very so much, right? So we are just stopping. Thank you for all.
Thank you for the time, and really it was excellent. Good questions and good interaction.
Thank you.
Thank you.